Do you believe that lurking just beyond our solar system, there could be a massive planet one scientists have been studying and searching for more than 100 years? A world that's cold and pitch black, out on the edge where sunlight grows so faint it almost disappears. Something out there seems to be making countless icy bodies behave wrong, as if an invisible hand is tugging them off their expected paths. So, has the century-long hunt for Planet 9 finally reached the end? Welcome to Atlas StoryTrail. Today, we're going to trace the history of planet hunting, then break down the 3 biggest fingerprints of Planet 9. And after that, new evidence that has many scientists believing we're closer than ever. But there's also a risk. We might be fooling ourselves because of observational bias. And in the end, the Vera Rubin Observatory may be the one that delivers the answer. Humans have discovered planets before by following tiny mistakes. Back in the 19th century, Uranus didn't move the way it should. Its orbit was out of rhythm. The mathematician Leverrier calculated that there had to be another planet pulling on it. Astronomers aimed their telescopes at the exact spot his math predicted, and Neptune appeared almost unbelievably accurate. That success created a powerful belief. If an orbit is off, then somewhere out there, a bigger planet is doing the pulling. In the early 20th century, people suspected there was yet another planet, and then Pluto was found. Even though Pluto was later reclassified as a dwarf planet, it left behind a legacy. It fueled a hunt for distant worlds that never truly stopped. But from here, the story gets harder. The farther out you go, the darker everything becomes. Closer planets can be spotted because they look like moving stars. But at distances of hundreds of astronomical units, a planet can be so dim it vanishes into the sky's noise. So the hunt for Planet 9 isn't seeing is believing. It's a logic puzzle. We watch the motion of small objects and follow the footprints of something we can't see. Beyond Neptune lies the Kuiper Belt, a frozen graveyard with thousands of icy bodies. Out here, gravity is weak, time is long, and even a small tug can build up into a huge change. Since the early 2000s, sky surveys have found more and more distant objects, and then something strange appeared. Some orbits didn't look random at all. If no special force is shaping them, those orbits should spread out in every direction. But instead, many of them look like arrows, pointing the same way. That's fingerprint number 1. Orbital clustering. The most distant objects seem to aim toward the same region, tilted at similar angles, like they're being held in formation. If it were only one object, you could call it luck. But when multiple objects show the same pattern, random chance starts to collapse. Konstantin Batygin and Mike Brown ran simulations. If there's a large planet far away, on a long stretched, tilted orbit, it can herd smaller objects into a stable structure. And here's the twist. These clustered objects often sit on the opposite side of where the hypothetical planet would be, almost like a natural way to avoid collisions and stay stable for billions of years. In simple terms, you don't see the puller, but you see the formation it creates. Fingerprint number 2 is even stranger. Detached objects. Neptune acts like a bouncer. Anything that gets too close gets kicked away or shoved into a different orbit. But then there's Sedna. Sedna's orbit is so extreme that it never comes close enough to Neptune to be strongly affected. So who pushed Sedna that far out? Planet 9 explains, over millions of years, this planet could tap objects gravitationally, gently, repeatedly pushing them farther and farther away until they detach from Neptune's control. And it's not just Sedna. Several other detached objects fit this same story. This is the most unsettling kind of evidence. Not a dramatic shove, but a long gravitational symphony. And the key point is, you need something massive, distant, and persistent to do this. A few random disturbances usually can't create a stable, repeatable pattern across many different objects. Fingerprint number 3 is the weirdest of all. Extreme inclinations. Some objects orbit the sun at huge tilts, and some even move backward opposite the direction of the 8 planets. Before Planet 9, there wasn't a clear explanation for why so many objects would get flipped out of the solar system's main plane. In simulations, Planet 9 behaves like an invisible conductor. It doesn't need to yank hard, just tug at the right rhythm. Over long time scales, small bodies get pumped into higher, more tilted, sometimes even reversed orbits. And when you see multiple different clues that can all be created by the same culprit, suspicion starts to turn into a serious hypothesis. Think of it as 3 puzzle pieces, clustering detached objects, tilted/backward orbits. If you're missing one piece, you hesitate, but when all 3 line up, the question shifts from is it real to where is it? And this is where the story heats up. Badajian argues the model doesn't just explain the past, it predicts the present. If Planet 9 exists, it should also create a stream of objects from far out, pulled inward, producing a group of bodies that cross Neptune's orbit more often. One study claims, if Planet 9 is real, about 3% of distant objects should follow Neptune crossing paths. If not, only about 0.5% should. They found a few dozen objects that match that category, and when compared to simulations adjusted for survey bias, the results lean strongly toward the Planet 9 scenario. Some videos even mention 5 sigma, an extremely high scientific standard. But there's a catch. The sample size is still small, and many orbits aren't locked down with perfect certainty. This isn't the ending. It's a warning bell. We've reached the decision point, because a true discovery doesn't just need a model that fits. It needs repetition, verification, and the elimination of every alternative explanation. So if the evidence is stacking up, why don't we have pictures? Because we can estimate the shape of Planet 9's orbit, but we still don't know where it is along that orbit. A single trip around the sun could take 10,000 to 15,000 years, meaning it could be almost anywhere. And its brightness collapses with distance. The farther the planet is, the darker it becomes. To see it, you need long exposures, stacked images, and telescopes pushed to their limits. Subaru, Pan-STARRS, the Dark Energy Survey, they've searched, and still no clear suspect. And there's another enemy, observational bias. We don't survey the sky evenly. Some regions get scanned deeply, other regions get skipped because of weather, telescope position, or interference from the Milky Way. So if we happen to look more in one direction, we'll happen to find more objects in that direction. That's why the astronomy community is split. One side believes Planet 9 is the natural explanation. The other side believes we're staring at an illusion created by incomplete data. And that's why the Vera Rubin Observatory matters. It's been compared to the most sensitive security camera on Earth, a huge mirror, a gigantic camera sweeping the sky fast and deep, again and again, like a 10-year time lapse of the universe. Once Rubin reaches full operation, it will discover countless new objects beyond Neptune, boosting statistics and reducing observational bias. If Planet 9 is real, Rubin will likely narrow the search area and may even capture it directly. If it's not real, Rubin may expose the truth that clustering was never a signal, only a side effect of where we happen to look. So maybe it's observational bias, or maybe Neptune migrated early in the solar system's history and trapped objects into strange structures. Some theories go even more extreme. A primordial black hole with the mass of a planet. Has the 100+ year search ended? The honest answer is not yet, but it's entering the final act. We have 3 major fingerprints: orbital clustering, detached objects like Sedna, and extremely tilted/backward orbits. On top of that, we have a new testable prediction, a flow of objects being tossed inward. And most importantly, we're about to get a tool strong enough to settle the case. If Rubin captures a moving dot of light behaving exactly the right way, history will repeat itself. Like Neptune, math leads the way, a telescope confirms it, and if Rubin finds nothing, science still wins, because then we'll know for sure we need a different explanation. Either way, Rubin's uniform data will help us understand the solar system's outer edge better than ever before. A real answer is coming soon. And you? Do you hope it's a giant frozen planet out there? Or something even more mysterious? Don't forget to subscribe, share, like, and drop a comment. How do you think Planet 9 could have formed?